record the class. And
Yeah, the class before that also it was same sensors. Sensors was actually a bit easy.
sensors are easy. Thing was I wanted to explain sensors to you in detail. So I wanted to talk about atoms and everything as well. But turns out that's a bad idea because not everyone is old.
Not everyone's that old to understand it.
All right, I'm not gonna delay us more. I'm gonna get started. Okay, so I think no one's new here today. It's like the sixth class. I'm just gonna skip through my introduction.
Okay.
Give me a second. And yeah, Facebook community. I have to plug this. Like y'all go join it so y'all can basically learn from each other. Can watch recordings. Can look at the schedule of the upcoming class and all of that. Right? So join the Facebook group if you
So
have.
it's on your Facebook page?
Sorry.
You have even a
Facebook.
YouTube channel, right?
Yeah, but
Yeah.
like I basically that's YouTube channel just to complement the Facebook page, and I'm muting all of y'all now.
I saw one over there. Okay, but
Use the chat, okay? Okay, and this is not what we're doing in today's class. This is just something I've stopped updating the index. It seems unnecessary. But like, okay, but today's plan basically is we're going to start with a short recap of a few things from the first class, and then we're going to a few things from like the previous classes basically. Like, I'm not going to explain them much. I'm just going to ask you all if you'll remember what they are, and then you're going to then we're going to start talking. We're going to go over sensors again really quickly. The same sensors that we did last time. Just going to talk about them a little more, and then we're going to start talking about the Arduino. And I know, has any of you ever worked with the Arduino before? Can you all raise your hand if you all have worked with the Arduino before, and then I'll give you all a chance to tell us what you worked on. Yeah, you know how to raise your hand with this thing? Yeah, okay, let's do this. Can you tell us what you worked with before, Kashmir?
I did. I made a simple circuit with. I made a circuit which you taught before. Then I made that one radar and one sonar, and then yeah, I made some locks and one I made a calculator.
Okay, that's nice. Okay. What about the others? Anyone else worked with the Arduino? Okay, how many of you all know what is the Arduino? Or have heard of it before?
I already explained.
Ishan, are you going to tell us? Wait, where's Ishan? Nope. Zoha, what about you? Never mind. Okay, Kashinath, you can lower your hand. Anyone else? I will take that as a no. Don't be shy, man. Come on. Anyway, so okay, Shreyas, can you tell the others what have you worked with? Alden, do you mind telling others? 1 second, Shreyas. Where are you? Okay, Shreyas, do you mind telling us? I've unmuted you.
Sir, I made a circuit which lights up the LED in the dark.
Oh, okay, which lights up an LED in the dark. Fine. So
Yeah.
today we might not do sensors with the Arduino. Today we are just going to do lighting up an LED with an Arduino. We make it blink and do something like that. Okay. Good. Anyone else? Alden, do you mind telling us? Okay, Alden, do you mind telling us?
Yes, I have done a project for Arduino with an Arduino. I have done a project called gas leakage detector. I have used an Arduino for it.
Okay, and what did the project do?
It detects the gases. Like if the gas is leaking, it detects it.
Okay, that's nice. All right, I see a few people have just joined us. So to let the latecomers know, we are going to be doing a bit of a recap from the first class today, followed by working with the Arduino, understanding the board itself, and basically the different parts of an Arduino. Give me a second. Sorry, guys. Okay. No, we're not going to actually code today. We're going to use a block-based programming for this. Nothing. I have this person at home called my sister. She's not the never mind. Let's not go there. Anyways, so then we're going to start talking about basically the structure, the different parts of an Arduino, and we're going to just scratch the surface of basically how it works, how the code works, and we're going to be doing a very simple project with the Arduino. All right. Right. Okay. So let's get started. So let's start with the recap. Like I said, we're ignoring the exception today. So is this Zoom AI inspector a real thing, or is just one of your students? Doesn't matter. Anyways, so basically what we, yeah, I'm unmuted now. You can hear me, yeah? Okay. So now can you all spam the chat and tell me what you all have on the screen? What is this thing called? I'm sure all of you all know. What kind of a motor? What kind of a motor? Nope, not stepper. But yes, it's a DC, not servo either. It's a normal DC motor. That's it. Don't actually spam a bit on me. But okay, sure, you can participate, whoever you are. Right. Anyways, so y'all basically this is a DC motor. All of y'all know that. Next, what's this called? I know it's a switch. What kind of a switch? Be specific. Yeah, I don't know what the Zoom inspector thing is. It's an AI listening to my classes. He's welcome. Yeah, it's a rocker switch, exactly. And does anyone here not know how does it work? Nope. I am gonna take it. So like any of these concepts, if you have a doubt, then you can let me know and I'll explain it, or else it's pretty simple. It's just basically like it's a part of a circuit. There's a piece of metal. There's a piece of metal that basically when it's in the off position, it touches the contact. The contact stops, so it closes the circuit. When the circuit is in off position, the metal contacts are disconnected, forming an open circuit. I think, yeah, everyone knows that. Okay, this thing's kind of creepy. I might kick him out. Next, what is this thing called? It's a slide switch. That's right, Farhad. What about the others? 1 second. This is a slide switch, exactly. And I think you all know how slide switches work. And if you all don't, I can explain this in a minute. So I'm going to do it anyways. That being said, right now, yeah. Give me a second. I need to pin my own video because I can't see it. Yeah. So very simple. 3 terminals, 1, 2, 3. A metal piece inside of it that's connected to this. Connected to the plastic handle that looks like that. Wow, what a scam. Try to make that yellow. A plastic handle here. This is one position where these two get connected basically. And then this is the second position. Yes, it can be seen in our toy cars and everything. Yeah. And this is the second position where basically these two are connected. Like that. And these two are connected. Look. Okay, it's as simple as that. There's a metal piece inside that you're sliding between terminals. Simple. Next. What is this called? Merlin, we're just doing a recap and then we're going to start talking about the Arduino. Nothing much that you missed. Guys, tell me, what is this? Okay, next, what about this? Yeah, that's a toggle switch. That's right. Toggle switch pretty similar to the rocker switch. Basically, in one condition, there's like two contacts touching. In the other, they're not touching. Two contacts in one position, there's a metal piece pressing both them, closes the circuit. Other position, it's open, does not. This is a push button. And in what way does push button connect? If four terminals, that's right. And if this is a push button, thank you to the guys who didn't let me complete the question. Guys, come on. I'll take it that I'm an amazing teacher, and so you guys can answer before I even ask the questions. So if this is one gets connected to 4, 1 to 4, and 2 to 3 when I press the button. It's as simple as that. Okay, so this is what I didn't tell you last time, and something that you also know. Now the thing that on the inside of the switch, we call it the diagonal rule, but what is actually happening, and I was actually a little unsure about this myself, and that's why I didn't tell you all. But then I went back and checked this recently, and doesn't turn out. But the way the switches have been designed, this end, that's terminal 1 and terminal. Okay, and terminal 1 and terminal 3 are connected to each other directly. Okay, and terminal 2 and terminal 4 are directly connected. So what is happening is when you press the button, it's basically these two get connected to each other when you press the button, and when you release it, and when you release the button, they're disconnected. Does that make sense? Like, so if I were to plug in something on this side, I don't know which button. Okay, so basically if I were to connect something to this side of the circuit and to this side, irrespective of the whether the button is pressed or not. Okay, Zoom AI, I get it. You're very busy. You can attend as many education meetings as you want. I will not stop you. And basically, irrespective of whether the button is pressed or not, 1 and 3 are going to stay connected, and 2 and 4 are going to stay connected. Does that make sense? Yes? Okay. Right. And what is this thing called, guys? Yeah, I'm not going to start explaining this because it takes a lot of time and I've explained this way too many times before. Is there anyone who has doubts with this? I hope not. Yes, it's a voltage dividing circuit. Yep, it's a voltage divider. Any doubts, anyone? Nope, I am moving ahead. Stephen, you can watch the recording in case you do not know what this is. What is this, guys? Yeah, it says it on the screen itself. What am I explaining? But what does a thermocouple do? What does a thermocouple do? Yes, it measures temperature. It's a temperature detector. So I see some of you all were a little uncertain. So quickly going to tell you what it does again. So thermocouple is made out of two different materials like this. So this is one metal, two different metals that are really closely attached and are connected to each other on the top. Okay. One second. Okay, so they're connected to each other on yeah, they're connected to each other on top. And so you'll remember last time I told you all we're going to stop referring to them as electrons. We're still going to stick to power carriers. So you know a wire, even when it is not connected, has some amount of power carriers present in it, or just electrons. Okay, normally any metal is going to have electrons. Everything will have electrons in it, right? Any metal that we see around us is made of atoms, and atoms have electrons. So any solid object around us is going to have electrons in it. Yes or no? Yeah. So now what happens here? Right. Yeah. So what happens in this case is basically in case of metals, you know, in metals, these electrons or like power carriers can flow freely, right? Yeah. So in metals, these electrons or power carriers can flow freely. So what happens is when you heat one side of the metal, ignore him. That's okay. Zoa, ignore him. Okay. He's just in the chat. So when you heat one side of the metal, what happens is these power carriers or electrons flow to the cooler side. Okay, so now, okay, if a place gets hot, you would want to go to a place with normal temperatures, right? So electrons are also divas like us, and they cannot take high temperatures, and they're gonna naturally move to the side which is cooler or at a lower temperature. Okay, so when you heat one side in a thermocouple, electrons from this side, electrons from one side are going to move to the other side. Okay, and as they're two different metals, the number of electrons that can move will be different in both cases. So these electrons that at first were equally, placed like that, it's not convection, but, and so the electrons are like that. Just assume it's in the metal. Okay. Yeah, basically, listen, Razak, I'm still explaining. So these electrons or power carriers that are in the metal are evenly spaced out. They're spread equally across the metal. For example, now I'm going to heat up one side. Remember, guys, my amazing drawings. Okay, I'm heating up one side. Okay. I'm heating up one side, and like I told you, the electrons, you can say, we feel uncomfortable. I'm just using analogy here to explain it to you all, and they're going to move to the cooler side. So obviously this side is much cooler than this side. Yes or no? This side is cooler. So the electrons from this side, let me get rid of all of the electrons. Okay, Zoom person, if you have doubts, then let me know, or else stick around. This is just funny, so I don't want to remove him. So what happens is when you heat one side and the other side is cooler, electrons are going to move to the cooler side, right? So they're going to accumulate on one side, on this side of it. 1 second. Yeah. They're going to accumulate near this side, the cooler end. Okay. So now, because they're two different materials will have different properties. And as they have different properties, the speed at which the electrons can move will be different as well. Does that make sense? Yeah. So because they are different materials, the speed at which the electrons can move will be different as well. And so more electrons, for example, the metal that is in red will have more electrons accumulated on one side than the other side, which will have lesser electrons. Does that make sense? Okay, Marilyn, basically what I'm saying is the electrons spaced out. Let me look for something. Okay, wow, I've got the perfect thing. I've got two metal strips. Okay. Yeah, wait, Jatin, I'll come to that. So, and these two are connected over here. Now, electrons are spaced out almost equally throughout this metal. Now, I heat up one side of this metal. Now, electrons don't like the heat. So, they're going to move to the cooler side. Okay. And because they're different metals, different materials, the speed at which they move to the other side differs. So, you understand how the electrons are going to accumulate on the cooler side. They're going to crowd there. Yeah. So as they're going to crowd there, one side will have more electrons than the other side because they're moving at different speeds. Yeah, and as they're moving at different speeds, one side is going to have more electrons than the other side. So it basically acts like a battery. Yeah, I'll build a shrine for the inspector after the class, but right now you'll listen and respond. Yeah, because one side has more electrons than the other side, you can say that end of it acts like a battery. Yes? Okay. Right. So this side of it acts like a battery, and as it is acting like a battery, we can measure its voltage. Yes or no? Right? So as he's acting like a battery, we can measure its voltage. And if the temperature, okay, one more thing that you should know. Now, if the temperature, for example, is just 10 degrees above normal, then some electrons will move to this side. But for example, if the temperature is like 100 degrees above normal, then obviously more electrons are going to move. And then there's also the speed factor. So considering both of these, the amount of crowding that will be on both sides will be different. So if the amount of crowding is different, the voltage that will be measured will be different. So therefore, as temperature will change, the voltage that you will get from the thermocouple will change. And you just calibrate that and you have a working I cannot show this in Tinkercad. Tinkercad has a different temperature sensor with a built-in voltage divider, so I can't. Sorry, but yeah, but basically as temperature changes, the voltage will change. Does that make sense? Yeah, we're revising again. Everyone got this? Anyone who didn't get this? Okay, I'm moving on. Next. Okay, this is pretty simple. Wow, this an RTD. Exactly. So, okay, let's do this time. Anyone here who's willing to explain to the class what an RTD is? I mean, I realize the classes are not as interactive, so maybe let's do that. Anyone willing to explain what an RTD is? Raise your hand. Oh, looks like someone forgot to upgrade Zoom. Nope, no one. I'll pick someone at random. Who here knows what's an RTD? Alan, will you tell everyone what's an RTD? How does it work? No, no one. Oh my God, you guys are very shy. Advik, will you explain? Jatin, guys, I want someone. Why you are shy? Just explain. There's like 30 people. That's it. No, 25 people. 3 of them are me. Nope. Okay, I'm not wasting time. So basically, an RTD is a type of resistor whose resistance changes with temperature. Now, all of you all know what resistance is, right, of a resistor? Yeah. So RTD is a special type of resistor whose resistance changes with temperature. It's as simple as that. And what kind of a circuit can measure a change in resistance? Guys, tell me, what kind of a circuit can measure a change in resistance? That's right, Jatin. A potential dividing or a voltage dividing circuit can measure the change in resistance. So this is what the circuit will look like basically. Okay, and I'm going to quickly draw it for you all. I hope it makes sense to you all. I mean, I don't know. We're going to have a battery because every circuit needs a power source. We're going to have one fixed resistor of whom we know the resistance. And we're going to have an RTD here. There. And an RTD here. And we are going to have a voltmeter connected over here. I'll explain this to you all in Tinkercad later. And we have a voltmeter here. It's as simple as this. So now you all know this is a, can you all recognize this is a voltage dividing circuit? Yeah. So everyone sees, and and remember how we observed last time, as resistance changes, the voltage reading is going to change. Okay, and now the thing with certain materials. So now this is what happens with normal metals. Okay, as the temperature increases, the resistance increases. Okay, that is a very common property of all metals. I'm getting rid of my RTD circuit. What a beauty it was. Okay, so with normal things, normal metal, most metals, what happens is, as the temperature increases, this is temperature, this is just a graph, simple graph, where this is temperature and this is, sorry, this is resistance and this is temperature. Okay. Uh, okay, wow, guys, I have got marks now. Question answering focus A star. I got a B in speaking. I'm sure my English teacher is proud. Guys, if this was a prank, please let me know after the class because it was hilarious. Anyways, uh, coming back. Wait, Zoom Inspector, can you give me a free Zoom subscription? I mean, I'm using my schools right now. I'd appreciate that. Thanks. Right. Yeah, I've emailed you about that already, so maybe check that. Anyway, so the thing with the resistance and the temperature thing is, with most metals, what happens is as the temperature increases, the resistance first remains the same and then suddenly increases. So measuring this with a voltmeter is difficult. But in some special materials like platinum, what happens is with temperature and resistance, you have a linear, no, he's not. He's no, you have a linear relation. Hey, I mean, schools in other countries are getting it for free. Do the same for UAE. Why am I wasting my time? Basically, there is a linear relation between resistance and temperature. So as equal amounts of temperature increases, equal amounts of resistance increases. Okay. Right. Moving on. Next. What is this called, guys? It's a motion sensor, exactly. So, do you all remember what PIR stands for? Exactly, Jatin. It's a passive infrared sensor. So it's called passive because it does not take any energy from anything. All it does is, it does not take energy from anything. All it does is measures heat. So if I take a PIR sensor and, where is this? Where is the PIR? Wow. It's not here anymore. Anyways, so what a PIR sensor does is, if I place it at the top of a room, it's going to make a map, a heat map of the room. So, you know, humans radiate heat. So it's going to see where are the radiation hotspots, and it has two ranges, two areas that it divides the room into. So if that high heat signal moves from one side of the room to the other side, it detects motion and and it detects motion and it triggers a certain action, whatever you program it to do. And yeah, so like I told you, all humans and animals, they radiate heat like that. And there's a Fresnel lens placed on top of it. Wow, you guys remember that focuses all the heat radiations onto a single point. And this is how you would make a PIR circuit. You know what we're going to do? We are going to make this circuit in Tinkercad right now because life is. Never mind. Give me a second. Are you all understanding everything so far? No, I mean, I almost believe that the inspector guy was real until he threw the zoom@gmail.com to me. Yeah, you're understanding everything so far? Because look, after this, we're going to start Arduino immediately, and we have a lot of slides for the Arduino. And 1 second, guys. I have to sign in really quick. Excuse me. Can you guys not bother with him? He's just some student probably. I'd appreciate if you learn instead of disturbing, not disturbing, but wasting your time. Okay, guys, I'm waiting for this to turn on. Give me a minute. But you know what? Till then, understand the circuit. So a PIR basically has 3 pins. Okay, the 3 pins are input, like a positive 3 point positive 5 volts, ground, and a signal pin. So what it does is, okay, it's as simple as this. So it's as simple as this. Even the PIR sensor, the internal circuitry of a PIR sensor, basically make it like a switch. So when it detects motion, it connects the 5 volts. It connects the 5 volts that you see here to the third pin. Okay. What it does is it connects the 5 volts, the power pin, to. Okay, guys. So the thing is, I'm not using a paid subscription of Zoom for today's class. So this meeting is going to end in a minute. Can you all rejoin on the same link? No. The class is still left. Just rejoin on the same link, okay? It's the same link. Just re-click and rejoin after a minute. Less than a minute. Because it's a time limit thing. Okay, guys, just give me a second. I'm just restarting this. Just have to restart the meeting. Okay. No, I'm just restarting it, okay? Just join back in after a minute. After I restarted it. Oops. Right. Okay, sorry to the guys who weren't here in that case. I'm coming. Okay. Coming back. So basically, you all know they made the circuit easy, and they also came up with a very simple programming language for you all to program the Arduino. And they made a very intriguing, or like actually a very simple software for you all to start programming with it as well. It's called the Arduino IDE. Where did I leave my pen? Yep. So it's called the Arduino IDE. I stands for Integrated Development Environment. Does that make sense? Guys, give me a second. Oh, no wonder. Guys, how about y'all focus instead of reading the chat? I'm talking, right? So you guys look at that, ignore the chat, okay? I'm not putting anything in the chat. So keep the chat closed unless you all want to read something or tell me something. Fine? Don't waste your time. Okay, so this is called the interface that you see on your computer on the screen right now is called the Arduino IDE, and it is a very simple software with a really simple programming language built for you to program the Arduino and program the microcontroller to do different things. How cool is that? And apart from Python, which I'm pretty sure all of you would have heard is a programming language, the Arduino's programming language is, you can say, the second most simplest language to learn and start using. It is super simple to use, and that's why we thank the developers for making it that easy. And it's called an integrated development environment because you can do everything from testing your code. You can do everything from testing your code to compiling it and uploading it in the same software. So it is one environment where you can code, program, test, upload everything. Wow, I said code and program separately. My bad. Does that make sense? Yeah, Kashinath, if you know Python, this is slightly harder, but it's different. It's completely different, but it's pretty simple. And they removed all of this and the need for even this. Right, like I said, the Arduino IDE, very simple free software. Look, everything is free. And they have pre-programmed functions and everything is very simple for you all to use. But in these web series of me teaching you all, I'm not going to be teaching you all how to code. Is that for everyone as well or just for Kashinath? No, I think it's just for Kashinath. Yeah, so in this web series, I am not going to be teaching you all how to code. Let me complete, guys. I'm not going to be telling you how to type and code, but I'm going to be using the blocks and Scratch like programming to program Arduinos, because obviously that's simpler. Okay, and you can use it to do everything that you'll need. Wow. No, not next class. It's going to be after a few classes. Don't worry. Yeah, no, I will have to restart the class because I'm not leaving until I complete this today. Next. So now what you see on your board, and like I showed you on the camera like 100 times, is basically called the Arduino Uno, the most common kind of Arduino board, and it has a microcontroller. All the circuit is on all this programming things here are to simplify simplify the programming bit, and everything that you would need from a simple microcontroller is on this board right here. One second, man. This is a big problem. Hold on. Okay, right. See, Omar, if you really want to do things like this, take two devices, keep your real self in the class, and you waste your time with the other device. So I can throw the other one out, but you can still listen. Okay? Coming back. Now, right. Now, basically what you have on the board is the Arduino. I'm going to be talking about the different parts of the board, the different kind of pins, and what we use them for as well too. So now, like I told you, this is the heart of the Arduino. It is called a microcontroller. It is basically the main brains that gets programmed and controls everything that happens on this board. Okay, so Arduino itself is like a motherboard, and this is like the head, the brain itself. And we use the circuit to program it, and we connect different things to it in different ways to control different things. Now the chip itself that is used on the Arduino is from a low cost company called 80 Mega. Sorry, the company is called Atmel, and the chip on an Arduino Uno is called an 80 Mega 328P. Okay, an 80 Mega 328P. That's the microchip. So what you can do is I can actually take out the microchip from this and build my own circuit, like with the same kind of programming components, and I can actually build the and actually use the functions I can on an Arduino as well. So it's actually just this chip, and everything else is just to support the chip. So main brains and main fancy part of the Arduino is this 80 Mega chip, which the Arduino does not make itself. These are like very cheap. You can buy them for like 1 dirham, 2 dirhams online, but you have to spend all that time soldering the rest of the circuit and all of that. That's, if you can do it, then do it. Next, now this is like a small part. Okay, now we're going to be first I'm going to be talking about different components around. Thank you, Zoa. Different components, and then, as you can see, I got this from a YouTube video. No, yeah, I got this from a YouTube video screenshot. There, that's why. Yeah, so now we're going to be talking about the different electrical components that support the main microchip on the board. What did you know? So the very first one is something called an oscillator. An oscillator basically controls the speed at which the 80 mega chip thing operates. One second. Where is my oscillator? Can you all see this thing here? I don't know if you can see it. Where is it? Here. Where it's very tiny. There. That small thing. That's basically an oscillator that controls the speed at which this whole thing runs. Okay. And yeah, I was basically looking at something to do with the oscillator thing. That's why it's in my suggestions. But you know what? See, guys, I also have to learn to explain some things to you all. Okay. And I also watch a lot of YouTube videos about them, but it's just so you all can understand. No, all of this is not YouTube, by the way. They are just few screenshots that I took from YouTube. Okay. See, never mind. Yeah, I'm not letting YouTube take credit for my work on the presentations. This takes time. Okay, so now this here is a small Atmel chip that is used to program the microcontroller. Basically, it is used to connect. Give me a second, guys. This is basically a small chip that is used for the USB port to communicate with the microcontroller. And this is a small board that you can say acts like a translator. Make sense? That's what it does. Next is a 9-volt DC power jack that can be used to connect to that can basically be used to connect to power. It's called a power jack. It can be connected to anywhere between 5 to 20 volts. Anywhere between 5 to 20 volts. But the main microcontroller on the board, main microcontroller on the Arduino that we saw here, can only run on 5 volts. This can only run on 5 volts. So obviously we are going to need a circuit that can reduce the 20 volts to 5 volts. And that is basically what, yeah, this is called, let me clear this. This is called a power jack that can be connected to 5 to 20 volts. And no, we don't use a resistor. A resistor is good to limit the amount of power, but it has a lot of limitations. Okay. Oh wow, yeah, only 3 minutes are remaining. After 2 minutes, I'll restart. Then can you all rejoin again? I'll take care of this meeting limit thing by next class. Okay, don't worry. Right. So, like I said, this 5 to 20 volts needs to be reduced to 5 volts. That is why the Arduino has a 5-volt voltage regulator on it. Later. 5-volt voltage regulator. Whoa, okay, they've stopped spamming. Ishan, stop spamming. Right. So the board basically has a 5-volt voltage regulator on it, and what the voltage regulator does is takes the 9 to 12 volts from the power jack, and it steps it down to 5 volts. And no matter what it is, anywhere in that range, you will get a common 5 volts that goes to the rest of the board from that. Pretty powerful chip. How it works, I'm not going to get into because it's pretty complicated, and it's like it uses a voltage dividing circuit with like a Zener diode or like a silicon processor, stuff like that. So I'm not talking about it. Then the Arduino has a reset button on it. There. Step down basically means reduce. So what this does, the reset button does, is it resets the code. It's basically like a restart button that you have on your PC. That's all this does. When you press it, it restarts the Arduino. Done. Wherever in your program, like for example, if your program is like this, blink LED once, then wait for 5 minutes, then blink again, then wait for 15 minutes. You can be blinking it now, and then you can be like, no, restart from the top. And that is basically what this thing does. Make sense? What it does? Anyone who didn't understand? Step down basically means reduce amount. Guys, any doubts? I'm gonna wait for a minute because you'll have that. Oh, the meeting is ending. Just rejoin. Just rejoin. Okay, same link.
When will this be coming and going?
Why are we doing like this? Going, coming.
Okay, guys, I'm sorry about that. Okay? It's gonna be the last time. Like I'll take care of this whole thing because yeah, I don't have a Zoom.
Want to be 4.
Yeah, I'm gonna teach
And
like
when
10,
the
15,
meeting ends?
15 more minutes and I'll do the quiz. Okay, I have a quiz.
Doubt.
Oh yeah. Okay, so
Okay, I just muted you very rudely. Who has something to say?
Sir, it's Dave. I have a doubt.
Yeah, ask him.
Sir, the one which controls that speed of that, the first thing you said, afterwards you said some speed controlling thing, no, in that Arduino.
Yeah, the
Are
oscillator.
there those, yeah, those, I saw many of them in the Arduino. So, are all those
are oscillators?
No, they all have different functions. They look the same, but they have different functions. So like this small thing here, it's called like this thing here, this metal thing here. This is also a different kind of oscillator. So like there are different kinds of oscillators that perform different functions that are on different parts of the board. I'm muting you so you can ask me questions in the chat. But yeah, they basically have different functions, and you know, like I told you that like one board itself had like 2 different kind of microcontrollers, right? So when the same board has 2 different kind of microcontrollers, then you can expect each microcontroller to have its own oscillator and all of its surrounding components as well. Give me a second. Okay, the chat is not opening, so if you have any cards, I probably can't see it. There it is. Okay, next. So you all understood what the reset button is, and I'm guessing you all. Okay, next. Now we're gonna move on. Like you can see the different pins around the Arduino, right? And all of these pins can get connected to different components and can perform different functions. Okay, and now we're going to be learning about the different parts of the Arduino and the different functions certain pins have. Give me a second. Again, what is happening? Okay, this is better now. Okay, nice. Right. So the very first and the most important part of the Arduino are the power pins. The power pins are located on which side? This side of the board, near the microcontroller, and you can see the enlarged view of them on the screen. Okay. Give me a second. Again. Video. Right. So you all remember how I told you all there's a power jack that can be, guys, listen now, I'm telling you all each pin ka function on these power pins. Now these power pins, like the name suggests, control the power on the board that is coming in and going out of the power pins. Okay. You remember how I told you all the power jack can take between 5 to 20 volts? The power jack is connected to the win pin. Okay. So the win pin is can also be connected to a battery between 5 and 20 volts to the positive of the battery, and the other side has to be connected to ground. And it can be used to power on the Arduino basically. Next, you have the 5 volts. Now this 5 volt thing, what's special about it is it can be used to take in or give out 5 volts. So it's either regulated 5 volts output, or if you have, wow, yeah, I forgot to turn on that. You can either listen carefully then, Razak. See, Razak, you were discussing school lips. Listen. So the win pin is basically connected to the power jack, and it can take an input voltage, voltage in between. I've barely explained anything, just listen. So the win pin stands for voltage in. Yeah. Look, Kashinath, I'm just explaining the power pins which are on one side of the board, and I'm starting from the beginning itself. This is just the first pin. Win pin means voltage in, and it can be used as it is like the positive. It is like the anode of, like, how an LED there's an anode that gets connected to positive, right? To get power. This is like the positive of the Arduino. So if you're connecting it to a battery, the win pin has to be connected to the positive of the battery, and the battery can be anywhere between 5 to 20 volts. And the win pin is connected to a voltage regulator that reduces the 5 to 20 volts to basically just 5 volts. Next, now because we have reduced it to 5 volts, we have the option of either directly, if I have a 5-volt battery, I can either directly connect it to the Arduino, or I can use the Arduino as a regulated 5-volt power source. Like this pin, this 5-volt pin will either act like the positive to connect to a battery can either act like a positive for you to connect it to a battery for exactly 5 volts, or you can use this as the battery itself, as the positive of a battery to connect like to an LED, for example, or like a motor. It's just that these pins cannot give out too much current. Like the rate or the speed at which the power carriers flow from them, it cannot be too fast. It will damage these pins. Make sense? Guys, yeah. Next, it cannot be too fast, it will damage the pins. Then next to that is a 3.3 volt thing. So you would basically generally use this 5 volt thing to connect it to sensors and power sensors. Can you guys hear me, or have I just like disappeared or something? Yeah, you can. Okay. If you have any doubts, let me know, or else just listen, because this is pretty interesting. Next is like a 3.3 volt pin. And like how the 5 volt pin can be used as an input and as an output for 5 volts, the 3.3 volt pin can be used as an input and output for 3.3 volts. As simple as that. But you generally don't use it as an input because 3.3 volts is not enough for the Arduino to run. So you mostly just use it as an output, because Bluetooth modules and Wi-Fi modules run on 3.3 volts. So it is easy to have like the power converter on the board itself. So thank you, the Arduino creators, for that. And then there's finally the reset pin. The reset pin, we forget about that for now, but basically it is used to reset the Arduino by connecting it to ground. Okay, now can you all guess what the ground pin is? The ground pin is basically the negative of the board, or like the cathode. In an LED there was a positive and negative, right? So the negative is what gets connected to the negative of the battery. Similarly, in an Arduino, the ground is the negative of the negative terminal, and it has to always be connected to the negative of the battery. Any component that you're connecting on the Arduino, anything, all the grounds should be connected to each other. Okay, always. All the negatives are common and they're connected to each other. Does that make sense to everyone? The power pins. Next are the input and output pins. So on the Arduino, there are 14 input and output pins. So you all should know this about programming and about electronics and everything in general. The number of pins, or when you're counting in a list and everything, always starts from 0. Okay, it does not start from 1, does not go 1, 2, 3, 4. It starts from 0. So it's 0, 1, 2, 3, 4. These are whole numbers, not integers. If you're, or natural numbers. Why? Forget integers. I meant natural numbers. These are whole numbers, not integers. So they start from 0. Make sense to everyone? So as you can see, the pins, the input and output pins are numbered from 0 to 13. So there are 14 input and output pins. And as the name suggests, they can either give an input, take an input from a sensor or from something like that, or it can give an output. That is, it can give voltage out or something like that. And whether they give input or output is controlled by our big motherboard chip thing here. Okay, so now out of these 14 pins, there are 2. Guys, if you all want me to stop teaching and go to the quiz, I'll do that. Advik, Omar. Guys. See, guys, this is tiring, okay? This presentation is like almost 50 slides, more than that. Okay, we're almost done with the slides. But thing is, it takes time to make, okay? So let me teach, or else it gets frustrating. And then I lose motivation. Then I don't feel like taking another class. It's as simple as that. But I know you all want to learn, that's why I'm continuing. So out of the 14 input and output pins that take input and give output, as the name suggests, there are 2 special pins, that is 0 and 1, that are TX. Okay. Zuha, I have not put a number. I'm just going to keep teaching till this thing is on. Till your schools reopen or till summer vacation comes. If you want me to stop, you can just tell me. You know, I'll stop. No problem. So there are, I'm just being dramatic. There is the 0 receive pin and the TX pin. So what these do is they are used for serial communication. Okay, so they are used for TX and RX are used for serial communication. One second. Okay, so the thing with all the other input and output pins is when they're giving an output, they're just controlling the flow of power, whether power is flowing out of the pin or not, or how much power is flowing in. They're just controlling that. But if I were to send a text message, like actual text in the form of bytes, like 10100, something like that, you know, computers interpret what we are typing in the form of bytes, yeah, 01001, something like that. You all know that, yeah? Yes. So yeah, you basically know how a computer interprets data in the form of 01010, stuff like that. Now, what these TX and RX pins, all these other pins that 2 to 13 can actually control power. Okay, and you actually, it still has a lot to do with zeros and ones, but just try and understand basically what I'm going to explain. But basically, the 2 to 13 can control the input and output of power, but the serial pin 0 and 1 can take in like direct text input. Like instead of giving it a voltage value for like from like a sensor, for example, like a thermocouple. Okay, simply put, it's like this. All the other pins from 2 to 13, if I were to connect a thermocouple to it, they would read the voltage, and then I would have to program it to convert it into the temperature reading. But the TX and RX pins, they can be used to directly take the temperature as a number. It can literally understand text and give out text. It can receive and transmit text. RX stands for receive and TX stands for transmit. Wow, my iPad is dying. Yep. RX is receive and TX is transmit. Make sense? And they can literally take serial communication, which means they can basically take input and output in the form of literal text. And they're generally used to use when you're using Bluetooth modules or like Wi-Fi modules and things like that, when you're going to get data from like somewhere else or something in the form of text. And you also use serial communication to talk to the computer. I'll talk about serial communication more later, but just know they're a little bit different from the rest of the pins. Little special there. Okay. Finally, the analog pins. On the Arduino, there are 6 analog pins, starting from A0, A1, A2, A3, A4, and A5. Very simply put, these analog pins are the positive of a voltmeter. Anyone here who does not know what is a voltmeter? Who does not know what's a voltmeter? Everyone here knows what's a voltmeter. I've spoken about it enough times. It can measure voltage. So you remember how a voltmeter, even when we are using it in Tinkercad, a voltmeter had a positive and a negative. Yes or no? Voltmeter had a positive and a negative. All of these 6 analog pins are basically the positive of a voltmeter built onto the board, and they can measure voltage. Thank you, Ryan. Don't learn, I don't care. They can be used to measure voltage. Make sense? It's as simple as that. And wait, you remember how we've been talking about all these different kind of sensors and and like the thermocouple and LDR, and we talk about how the voltage changes because of the voltage dividing circuit, because resistance changes. Guys, you understand? Yeah, I'll tell you. Wait, remember? Yeah, the voltage changes, so you have to measure that voltage, right, to work with the sensors. Oh, okay. I'm gonna block changing names now, so the names you'll have are going to stay. Okay, not now, later. I'm going to do that for next class. Anyways, and the negatives of all of them, like someone was asking, all of the negatives are basically ground. I told you, for the entire board, whatever you're connecting, the negative is going to be ground. Okay, now I'm going to talk about the input and output pins for one more second. The way the input and output pins work is, like, at least for the input, for the most of it, the input pins basically take input in the form of voltage reading itself. Okay, and like the analog thing can, and the analog pins can, okay, I'm forgetting something. So remember how I told you the analog pins? I just told you analog pins are basically like a voltmeter, and this voltmeter has a range of 0 to 5 volts. Okay, based on the value of voltage between 0 to 5 volts, these pins assign the voltage value, a number between 1 and 1023. Does that make sense? So like, it's basically 0 becomes 1 and 5 becomes 1023, and every value between them has a value in this range. Understand? So that is basically how the analog pins work. They assign a number value between 0 and 1023. Okay, Farhan, I'll tell you quickly. Basically, the analog pins are like a voltmeter. They are like the positive of a voltmeter, and they can take voltage reading between 0 to 5 volts. Okay, And as they're taking a voltage reading between 0 to 5 volts, they use a mathematical formula to convert that value to something between 1 and 1023. So each number, for example, what is half of 5? 2.5. So 2.5 volts, if it's receiving 2.5 volts, that will correspond to half of 1023, which will be 511.5. Yeah, I think so. Yeah, 511.5. So that is basically how this would work normally. And it would, yeah, it would have a linear relation. It would use a mathematical formula, convert it. It's just for ease of calculation, it makes the value bigger. Now, coming back with the input and output pins, you'll understood how they take input, right? Similar to the analog pins, they take input in the form of voltage readings. And they give output in the same way by giving a voltage reading between, okay, they don't give a voltage reading between, by giving a voltage reading of 5 volts. So I can basically use the software to turn a certain pin, get it? To turn a, my God, to turn a certain pin on or off. And when you turn it on with software, you basically make it the positive end of a 5-volt battery. Does that make sense? It basically is like connecting it to a 5-volt power source when you turn each of these pins on. And when you turn them off, they'll be at 0 volts. It's as simple as that. You know what? Now let's do some activity. Yay! And then go on to the quiz. And right after this, I have a class until 5. Wow, this is tiring. Done something. Okay, new circuit. Let's just do that. No, Mikhail, I don't get paid at all. I'm doing this for free. I'm on incognito because my laptop stopped working, so I'm using my dad's laptop just for simplifying things. Okay. Yes, thank you. I have a name. Call me that. So I take an Arduino Uno in. Then I take an LED. Guys, I'm going to talk more about programming and a little more about the input and output pins again in next class. But right now, I just want you all to be a little excited about it. And remember how I told you when you turn a pin on, it gives out 5 volts? Let's see that with a voltmeter. You know what? That's for next class. We'll have fun with that next class. But right now, I'm just going to build the circuit. Next class, I'll explain the circuit and the code and everything to you all. No, wait, I forgot to code it. Simple code, pin number 12, that's where the LED is connected. Even yeah, that's where the LED is connected. So that's going to be it. And I'm going to start simulation. And you can see the LED is blinking, right? That's what it does. Turns it on. So power flows from that, waits for 1 second, turns it off, waits for 1 second. It's as simple as that. And okay, this is something that we can do just to look at. If I were to convert this into text, see, the software Tinkercad is so amazing. Not only can you program using the simple blocks, it converts it into text also for you to program, to make more complex programs after you're done with the base. So yeah, this is what the program would look like, and the elements of the program I'll explain in next class, and We'll talk about sensors, and we'll make more circuits with the Arduino, and we'll have more fun with this board for the next few classes. Basically, did you all get a fair idea about what the Arduino is? And are all of you excited to learn about it? Yes? Great. Okay, guys, so I have a request. I want to, before we go on to the quiz, this is a kind of request that I have, and I would really appreciate if you guys could do this. Okay, once again, I'll go to the quiz, but tell me if you all will be willing to do this. Now, you'll see this is my number on the screen here. Okay, on the top there. Now you all know, I like someone asked, I do not get paid for this, right? I do not have any direct benefit from the classes, except that I enjoy doing this, and it's like giving back to the community. And if you guys do things in the future, you all might remember me. So that is why basically I enjoy doing this. That's why I'm doing it. But it would really help me if you all could make like a short video, like a 1-minute video, like ask your parent or someone to record it, of y'all talking about the classes, or what you all like about the classes, or what you have learned from the classes. Okay, and share that with me on WhatsApp. Yeah, I have a LinkedIn account. That is my number. I'll leave it in the chat. No, if you all want, yeah, wait for the quiz. First, I want to can you all tell me how many of you all would be willing to make the video for me? Can you like raise your hand or something? Even if you all don't want to make a video, you all can like put down a paragraph and send it to me on WhatsApp. Just write like a small, like not, I won't call it an essay, like a few words about what you like about the classes, and do that. I would prefer a video. I'd really like it if you can make a video. Thank you, Alden. Okay, whoever can make a video. Thanks, Shreyas. Okay, that would be really amazing. Okay. Thank you so much, Alden. That just tells me you're learning from the classes, and it helps me a little bit too. And you're not supposed to see the question answers. Yeah, I'm using incognito today. Omar, aren't you fasting? And no, you're getting education. I mean, you're getting knowledge. You're not getting McDonald's. This is the quiz, guys. I'm going to send you all the link. I'm going to take it that few of y'all will be sending the video to me on WhatsApp. Oops, I'm supposed to send that to everyone. Here's the link. Jump in. Okay, Zoha. Zoha, see, I did not even have water in today's class, irrespective of me speaking, because I realized some of you must be fasting. Dedication is. Okay. Okay. All of you jump in, and please make the video if you all can. Or just write, if you're uncomfortable speaking in front of a camera, then just write a paragraph and send it to me on this. Okay, thank you. Alden promises to do it today, guys. So, like, if anyone else can do it, I'll really appreciate it. Thank you. Okay, thanks, Alden. I'd prefer a video, so see if you all can make a video. Try your best. Okay, thank you. And I'm waiting for you all to join. Okay, so now all of you have already joined the quiz, so we won't do this time. But next time, for sure, what you're doing is all of you are going to come up with like funny names for the quiz. Don't sign up with your real names. Okay? And then later tell us who you really were. I'll pick out like a funny name next time. But today, this is fine. Real names are fine. Don't exit and rejoin or something. But is everyone in, or should I start the quiz? I think a few more people are coming. Let's do it. Oops. Nope. Thanos' daughter, great. So you die somewhere in the line. Oh, tell that I can remove people from the quiz. Let's try that. I'm kidding. Okay. Guys, should I start? Anyone left to join? Wow. Okay, guys. No offensive language, though, okay? Let's have that as a fun exercise. I'm going to start the quiz. If you have a MacBook, then I don't know. If you have Windows, then press Windows and print screen. It takes a screenshot. I'm not tech support. Guys, I'm starting the quiz. Okay? There you go. As well, and the music was very annoying. I'm turning it off. And the survey link. Yeah, Kashinath. Kashinath is just in a hurry to leave. What is happening? Where is the survey link? Give me a second. I'll have to copy the survey link. 1 second, huh? I think it is this. Try this. Can you all try this survey link? I think it should work. Yeah, guys, can you all tell me if the link works? Yeah, I just sent it, man, in the chat. Yes, it worked. Okay, good. So that is the survey link. I don't know how I deleted the slide from the presentation by mistake, I guess. Omar, do the survey before you go, please. Omar, next time if you're coming, I want to see you with your real name. And I want to see you interested in learning. Okay? And guys, now I'm letting you all unmute yourselves. If you want to say something, if you want.
Last.
It's pretty boring.
Bro, can you show the results?
Yeah, sure. Can you all see them? So, Ayman
I
came
was
first.
in the 10th place. Let us see.
Ishan came second. Ryan came third. Jatin came fourth. And Aliza came fifth. Kashna came sixth. Why, guys? Come on. I mean, didn't I teach well? Why do you all do that bad in the quiz? I mean, you know what? Let's actually, you know what? Next class, I will discuss the questions from this quiz.
Thank you so much.
Yeah?
By the way, my name is Thanos' daughter because my dad's pretty strong.
Who's that?
Oh, okay. Right. Okay, so see, wait, I can actually tell which questions you'll have difficulty with. Okay, so, oh man, guys, come on. I told you all the interface is called an IDE. Arduino IDE. integrated development environment. Okay, few of you have got it right. So many get it incorrect.
Rishabh, I got it right, but I just did this mistake in the spelling instead of I wrote AUR instead of AR.
Okay, it's fine, it's fine. Then how many analog pins? Wow, 12 of you have got that incorrect. Come on, I told you it's 6.
I got it right.
In
Okay.
which they show all the 100.
Got this.
I got the interface correct, but instead of capital A, I just wrote small a. It gave me wrong.
Okay, okay, guys. I actually have to head to another workshop right now, which yeah, literally immediately. I thought I would finish by 3:30, but no. So no lunch for me today. But anyways, okay, guys. So thank you for attending. Hope you all did the survey.
Bye, Rishabh.
And yeah. Okay, bye guys. Did you all do the survey? Do the survey. Make the video, please, guys. Make the video for me, okay?
Bye bye.
Make the video. For
I'll
me,
try
please.
to send to you as soon as possible.
Okay, thank you. Send it to my WhatsApp. I'm not in university yet, so
Bye.
yeah, bye. Okay. Heard you the first time. Heard you the first time. It's okay.
Bye.
Bye. Bye, guys. Bye. Bye. I'm ending the meeting.
Welcome to the Scribbling Club, where we annoy Rishabh Java by scribbling on the screen.
What is this now? I have done the okay. Okay,
Bye.
Okay, guys, I do not know. Do I not pronounce words correctly? Or what is up with my speaking? I got Omar gave me a B as well. I'm kidding. I have to leave now. Okay, thanks guys. Bye. Take care. Okay, take care. Okay, send me the video if you all can.
Okay, bye.
Bye. Abhinami, how young are you?
9. I mean
Oh,
10.
are you able to follow what I'm explaining?
Kinda. I
Okay,
got almost every question wrong.
okay, fine. So you're able to understand a little bit, no? You seem very, very small.
Yeah.
Okay, okay, fine. So if you have any doubts, you can
I
message
look
me or
like I'm
email
in
me also.
second grade. Really, I'm not.
Yeah, you look very small. So if you have any other doubts also, you can message me, okay? I'll answer them happily.
Okay.
Okay, bye guys. I'm ending the
Bye.
meeting.